times table. It says that write a function that prints the 9 times table starting with 0. It gives the prototype as usual. Then what it does is that you usually see how they want a function to look like. So when I go back from work, I wanted to just glance through it quickly. I was analyzing it and I realized that there's a pattern to this times table that we see over here. So let's try and analyze this and then see exactly what the pattern is before we go into pointers. If you look at it carefully, you're going to realize that the whole pattern starts from 0. So all the first row has 0 numbers, 0 figures, and then the first column also has 0 numbers. So we see a 0 here. Then let's first count the number of rows. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then from then on, we have 1, 2, 3, 4, 5, 6, 7. So it starts from 0 to 9. So that's like 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And from there, we see 1, 2, 3, 4, 5, 6, 7, 8, 9. And we see the same pattern here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then from then on, you're going to realize that there is a multiplication going on here. So 2, 4, 6, 8, 10, all the way to 18. So you're going to see 2, 4, 6, 8, 10, 12, 14, blah, blah, blah. Let's not write everything because we don't have time. Then, because we don't have time, I'm not going to waste time writing everything. It's because I want you to see something. That's why I wanted to write a few of them down. Okay. Now I'm about to give you some codes and secrets. Like I tell you all the time. Yes, can you hear me? I think I'm going to go on. If he exits and joins back, we're going to have the record, so you can always listen. So can I proceed?
Yes, you can.
Okay. So, like I tell you, there are secrets to programming. And when you capture those secrets, life becomes easy for you. I explained to you in our previous meetings that whenever you see a pattern, the answer is straight to the point. It's a for loop. Not just a for loop, it's a nested for loop. So whenever you see a pattern, just know that 90% of the time, you're going to end up solving it with a nested for loop. So you have to be a master of for loops because you're going to need it a lot of the times in solving pattern questions. Then the next thing is that whenever you see a pattern, the outer loop is going to print the number of rows. I'll keep repeating that over and over and over and over and over because that principle is always the same. Okay, now watch this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The moment you see that there are 10 rows, which means that the outer loop is going to print 10 iterations. Don't think about it. Just know that that's how it's going to be. So we are going to have 10 rows. Then look at the number of columns. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we also have 10 columns. So the rows are controlled by the outer loop. The columns are controlled by the inner loop. Once you have this, 50% of the problem is solved. Okay, then now let's figure out the pattern over here. Realize that if you look at this carefully, everything is being multiplied by 0. 0 multiplied by anything is 0. Let me change the color so that it looks a little different for us to get what's going on here. Then if you look at everything going on here, you realize that everything is being multiplied by a constant, which is 1. If you look at everything here, you realize everything is being multiplied by a constant, which is 2. So let's try it out. This is 1 times 1 is 1, 2 times 1 is 2. So 1 times 1 is 1, 2 times 2, 2 times 1, and 3 times 1, 4 times 1, 5 times 1, 6 times 1, 7 times 1, 8 times 1. Stay with me. And over here, you're going to realize that the same thing is happening. There is a constant 2 over here. So over here is 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, 2 times 7, on and on and on. And the same thing is going on here. You realize that there's a constant, which is 3. So this is 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. You get it? The same thing is happening here. I'm going to end here because I'm not going to continue with the rest. So this constant over here is 4. Okay. So over here we have 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. So the figures that we are actually seeing in the pattern is a product. This is the logic that you use to solve questions. You analyze it, you realize that, okay, I see this going on here. So we realize that on and on and on, over here, we're going to have a constant of 5, we'll have a constant of 6, a constant of 7, a constant of 8, a constant of 9. Then let me complete the final 9. So this is 9 times 1, 9 to 18, 9 to 8, 27, 9 4. So realize that the final pattern is a multiplication of 9. So 9 1 9, 9 to 18, 9 to 8, 27, 9 4 36, 9 5 45, blah blah blah, on and on and on, all the way to 81. So now we have been able to decrypt this pattern. The question now is, what programming logic can we use to implement this? We have seen 3 things happening over here. Number 1, the rows, meaning that we are going to need a loop that will control the rows. It's like I'm thinking aloud so that you know how I think when I'm trying to solve a question. So we'll need a loop that will take care of the rows. Then number 2, we're going to need a loop that will take care of the columns. Now, if you look at the rows, you're going to realize that this is actually an iteration that is running, because we go 1, 2, 3, 4, 5, 6. This is an iteration that's running for the rows. Then if you look at the columns too, you realize that there's an inward iteration that's running. So all this 1, 2, 3, 4, 5 is an iteration that's also running, which is being multiplied to the constant. So these are the constants that they are being multiplied by. So an iteration is running throughout the row, and then the constant is being multiplied to the iterations. I hope that makes sense. I'm going to explain this one last time. So you realize that for the 2 times table, you realize that we have 2 1 2, 2 2 4, 2 3 6, 2 4 8. The constant that's running throughout this iteration is the constant 2. For 9, the constant that's running through these iterations is a constant 9. So we'll need a loop to take care of the rows, which is the constant. Then another loop is going to take care of the columns. Now the columns are the iterations that's going to be running. Okay. Then finally, you realize that each figure we see here is a product of the iterations and the constant. So we are going to need another variable or any element or whatever is going to take care of the multiplication, which is a product. You get it? So having come this far, we probably have solved like 70% of the question. Now we have the logic. So how can we go and implement it in code? Let's go try it out. Let me just open my terminal. And today I'm just going to go straight to VS Code because I don't want to waste a lot of time. Great, because it's a C file. You already know what to do. As usual, we're going to include a preprocessor directive. ALX is going to say you can use standard library, so you're going to include your main.h as usual. But because I don't want to go through the hassle of putchar, I'm going to include a standard library so that I can use the function putchar. And I'm also going to include stdio.lh as usual into main. My function is going to return 0. Simple. So let me go and copy the prototype of this function just like you do. Then I'm going to put a prototype in my main.h. That's why I've included main.h. Nice. Great. Then I'm going to come back to my file. That's it. Now let's work on our function. I'm going to put a prototype over here so that we can work on it. I hope you guys are still with me.
Yeah.
Yes, so far we've been able to see the logic of the pattern. Now the question is, let's try and implement it in code. How are we going to do it? The name of the function is times table. This is the parameter is void. It means it doesn't take any parameter. So we can just write our function and go away. According to the pattern that we saw, we're going to need a loop that controls the rows. We're going to need a loop that controls the columns. Then we are going to need the product of the iterations of the row and this constant. So right by looking at this, you can tell that we'll need at least 3 variables. So let's try our hands on that. Let's initialize some variables. Int. First, let's say this is a constant. Okay. Then we'll initialize another one that will control the columns. Then we'll initialize another one that will be the product. Okay. That is okay. Now, just like we've already explained, all these that you see are local variables. These are local variables because they are inside the main function. You realize that I have an error here because the const is a reserved word. So I cannot just come and say const. In the C compiler, const is actually a data type. So that means I have to change this to something else. Let's call it probably the constant. Let me find some short term for it. Constant. Yeah, let's just use this just for the sake of escaping the reserved word. So we have three variables right now. We have the constant, which is the one in the orange over here. Then we have the iterations of the rows. No, we have the constant, which is for the rows. Then we have the column, which will control the columns. Then we have another iteration for the product. But if you look at this carefully, you're going to realize that all the rows are printing an initial value of 0. All the rows are printing an initial value of 0, meaning that we are going to initialize our for loop at 0. Okay, so we're going to say that for our constant equal to 0, then our constant, how many times are we going to run the loop for this one? Less than or equal to what? Remember, we have 10 rows, so how many times will we run it? Anyone can just unmute and tell me. Less than or equal to 10 from 0, that's going to be 11. Exactly. I agree with Ernest. 9. Yes. You understand why, right? Because from exactly. Yeah, 0 is inclusive. So we run the rows the number of times. The outer loop the number of times there are rows. Very simple. You guys are really good now. Then we're going to increment it. You know why we are doing that. We open our curly braces for our outer loop. Then, as you know how nested loops are, before we say anything, we initialize another inner loop. We're going to say that this was going to control the columns. So our column we initialize from 1. Why are we initializing from 1? That's because even though you see 0 over here, if you initialize your column, your inner loop from 0, you're going to have a problem because all these first rows are iterating from 0. Let me just demonstrate it so that you see it rather than trying to explain. So let's first initialize it from 1. We'll also initialize it from 0 and demonstrate so that you see how both of them works. Then we're also going to print our column less than or equal to 9 times as usual. Then we will increment it as you already know. We open our curly braces for the inner loop. Just like I explained to you the last time, when you are working on patterns, the real drama occurs in the inner loop. Most of the time, what the outer loop will be doing is that it will just be printing a new line. The inner loop is where you're going to actually implement the code that's going to control everything. All right. So let's go and look at the pattern carefully, and then let's see what we are going to put what we are going to print. Definitely, we are going to print some form of product because all these we see here is a product. But then, before we print the product, you're going to realize in the pattern that there are also spaces and commas. So we need to put these spaces and commas. So just to help your thinking logic, let's first know that, okay, there's going to be a form of product. So let's put our product. So we are going to put This is not the ALX putcar I'm using. I'm using the standard library putcar because I don't want to go through the hassle of trying to set up the function putcar. Then we're going to putcar. Remember that putcar prints a single character. So I'm going to putcar product. Okay, but remember, I explained to you the last time that when you are using the putcar function, you cannot just put in a figure because according to the American Standard Code for Information Interchange, when you putcar a figure, it's printing something else which corresponds to the ASCII figure, the ASCII value. So the moment you are using a putcar function, you need to do a character conversion so that the putcar is not going to recognize the corresponding ASCII figure, but rather what you are actually trying to print. So this simply means that, who can tell me the syntax? We'll add to something. Thank you. Very simple. Very simple. You guys are masters now. So now, at least we know that we are going to print a product. But remember that putcar can only print a character, a single digit, a character. So assuming our product was going to give us 0, we are safe. If it gives us 4, because it's single, we are safe. If it gives us any single digit from 9 below, we are safe. But the moment it prints something which is a double digit, putcar, the law of putcar has been broken because putcar can only print a single digit. So then we have to come up with a logic that's going to take care of the double digits because putcar only prints single digits, and ALX says that you can only use the putcar function. Okay, so that means that the logic which we have been speaking about all this while is going to apply. since we cannot print double digits with putcar, we have to print single digit. Then you know that at all cost, we are going to go with what? This. Now, before the if, we are definitely going to have some if statements, but modulus. I told you there's a mystery of modulus 10, and there's also a mystery of any number divided by 10. And you are going to be coming across this so many times. You will come across them so many times. Because anytime you have to put car a double digit, this is a logic. And I explained to you the last time sufficiently. That's because if you want to, when you modulus, let's say 11 modulus 10, it's going to give a remainder. So 11 modulus 10 is 1. All right. Now, if you divide 11 by 10, it's going to be 1.1. But because both of them are integers, the decimal parts will be discarded. So we are going to have 1. So anytime you want to put car a double digit, this is the notation you are going to use. Memorize it. Let it stay with you. So you want to use put car to print number 16. The first thing you need to do is to modulus the first one. So you're going to do 16 modulus 10, which is going to give you 6. No, you're not going to do the modulus first. You do the division first. So you're first going to do 16 divided by 10, which will give you 1.6. But because they are integers, the decimal will be discarded. You're going to have 1. Then you come and do again 16 modulus 10, which will give you the remainder, which is 6. So it will be added to the 1. And you're going to have your 16 safely using put car. So you first have to come and put car this, then you now come and put car that. And here is the case we are trying to print this pattern with put car, meaning that we'll have to divide by 10, then we'll now come and do the modulus so that we can get the double digit. Very simple. So currently, we've been able to put car our product, but some of our products are double digit. So that means that we have to divide it by 10. Very simple. So product over 10 plus ASCII character conversion. Okay. Why is this highlighting the syntax though? Because I'm using a backslash instead of forward slash. Yeah, product divided by 10. Now we're making progress. Let's print this code. I know it's not going to give us the right pattern, but usually when I'm working, I want to see what's going on in the code. So let's print this code and see what we have so that we can. Okay, so it says that our main.h, we have a problem over here. So let's go fix it. After the main.h, there's no semicolon. So let me just run the code again. Let's see what we get. And the code is actually not returning anything because we've not called our function in the main function. So let me call this function. The name of the function is times table. The way to call your function, by now you guys should be familiar with this. Use the name of your function and the parameters to call your function. But here is the case, this function is void. There are no parameters, there's no return type. So all you need to do to call your function is to bring the name of the function and parameters. So now we've called our function. Let's run the code again. Let's see what we get. So as you can see, the pattern is printing only zeros. The pattern is printing only zeros. And why is that so? That's because the logic is not yet right. So let's go and then try and fix the logic and then get exactly what we are supposed to get. Now, when the first loop is done printing, if you look at the pattern very carefully, the first loop, which is controlling the rows, first is going to print 0, then there's going to be a comma and a space. But then there's something I want you to see. Look at this very carefully. If you look at the double digit, there is just one space separating them. But if you look at the single digit, there are 2 spaces separating them. And you have to actually factor that in your code. All right. And then if you look at the code, you realize that 0 is printed first by the outer loop. Then the iterations of the inner loop begins at 1. So the outer loop prints 0. Then the iterations of the inner loop begins at 1 and multiplies it by the constant which we've seen over here. So let's go and try and see how you can implement the logic of that code. What you want to do is first to put car, let's put car the 0 we see ahead. So I'm going to put car first 0. If you want to print 0 with put car, this is how you do it. You don't have to add it to any zero thing. So let's first put car 0. Then for the inner loop, after 0 has been printed, it comes with a comma. So we are going to print a comma first. Then after the comma is a space. So we're also going to print a space. So put car, and we print a space. Great. Then, so we see 0 printed first, a comma after the 0, then there is a space. For the single digit, there are double spaces. But for the double digit, only one space is separating them. That means that for the single digit, we have to print 2 spaces. Then for the double digits, we print just one space. So let's go and do that. First, we print a 0, we print a comma, we print our space. Then we now come and declare that our product, remember that the whole function is a product of the constant and iterations of the inner loop. So our product is going to be our constant, multiplied by our colon. Wonderful. Then when we have this, we can now come and say that now this is where the if statement will come in, Ishira, because if the digit is a single digit, we print two spaces. But if it's a double digit, the space is just one. So the moment you hear if, there is a conditional. So we have to bring in some form of if statement. So if our sure.
I just want to understand how it's so far. So for the outer loop.
Yes, this is the outer loop.
For the outer loop, we have put current 0.
Exactly.
Because all the zeros, the zeros count are for the outer loop.
Yes, right? Yes. All the rows are for the outer loop. Think about it that way. The rows are for the outer loop. So you're not only seeing the figures in there, only see the line. So this time around, I don't want you to see the product itself. When I talk about the rows, I'm only talking about the count of the rows. So all the rows you see over here is the outer loop that is controlling the rows. Then the inner loop is controlling the columns. So the reason why we first had to put car 0 is that if you look at the inner loop, the iteration of the inner loop begins at 1. So all this 0 over here is under the control of the outer loop before we actually even begin the iterations of the inner loop from this point forward. This column forward is what? Come again.
The very plain.
Okay.
Yeah. Now the second code. Okay, so now for the comments and the spaces, they are in the inner loop because that's what the inner loop control. That's why we are putting the put card under the
yes.
Those put
yes.
Comma in the space.
Exactly. Exactly. So we are going from point to after the 0 is printed. Now we see the comma and the space. Then the comma and the space runs through everything. So we bring the comma and the space because right after the 0, the comma and the space is start. So we want to start looping that so that it applies to all the product. Then now we come down and say that our product, which we already know, is a constant of the row times the column, the iteration of the column. Because the column is going to iterate from 1 all the way to 9. So the iterations of the column times the constant, which is in the orange ink over here. So this is the constant you see over here. I hope that makes sense.
Yeah.
Okay. So right after we declare our product, just like I've already explained to you, whatever number divided by 10, because they are integers, the decimal will be discarded. So this one gives us the first figure if it is a double digit. The product divided by 10 gives us the first figure if it is a double digit. Really simple. We are now come to say that if our product is less than 9, and we open a code block for this, then we are going to put car space, an extra space. Because I explained to you that if you watch the single digits, they have double spaces, and then the double digits just had one space. So this put car over here takes care of the single space for the double digits. But then for the single digits, we need an extra space. So that means that we have to declare a space over here again. So if the product is less than 9, then print an extra space. Then we come out of the if statement and say that else. To open a code block for the else statement, we say that just put car our product. We are going to go for the modulus now, modulus 10. And as usual, we're going to add it to our ASCII conversion. Then, for the outer loop, we are just going to print a new line because that is what controls the rows. We're just going to put car. Yeah, go ahead.
So the else statement here will print the single digit.
Exactly.
But
exactly.
The product less than 9 will only print the spaces before.
No, you're right. if statement is going to print the extra space before the single digit, because there are two spaces over here. So if it's less than 9, then we need an extra space. This PUTCA product divided by 10 plus 0 is what takes care of the first. If it's a double digit, it takes care of the first digit of the double digit. So we have that taken care of. But the question is, what if it's a single digit? If it's a single digit and you divide by 10, then that means that you're going to lose a digit. It's going to be 0. So that means that we need another function to take care of if it is a single digit. So we are saying that if the product is less than 9, print an extra space. Else, just print the product modulus 10. And the product modulus 10, because it's a single digit modulus 10 gives us the same number. So this.
So that code is printing all the second figure.
You're absolutely right. You are 100% spot on. You're 100% spot on. So that second code is printing all the single figures for even the double digit, and it is also printing the single digit. Very simple, very, very simple. Let's run this code and see if we come up with some errors or we get the right thing. And it worked perfectly. No, it doesn't. It didn't work perfectly. We have an issue. I see more zeros than I should see. So this is so that the double digits seem to be working okay, but then we have an issue with the single digit. As you can see, the double digits are working okay, but then the single digits are not being printed. So right there, you'll be able to tell that the problem that we have with this pattern is that we need to go and fix something about our single digit, because the double ones are working okay. So let's go and debug and find out what's wrong with our code. So if our product is less than 9, we are printing a space. Then else we are printing the product modulus 10 plus 10, which is in the else statement. Now this new line is being printed by the outer loop. Let's go up and let's see what we have here. So our loop is working fine here. Our inner loop is also working fine here. Our product is also declared all right here. We are printing the first digit, which is the product over 10 plus 0. Everything seems to be working fine here. So I don't know where the problem is coming from. Else, the problem is definitely coming from the else statement, because this is what the loop, this is a statement that controls the single digits. So we need to fix something here. Either it's supposed to be out of here, it's supposed to be in another column, or I don't know. So let's try and move this out of here and see what we get. So let me take this out of this block.
I'm actually thinking the star function with the
Coming.
divided by 10.
Uh-huh.
It's supposed to come after the else, together with the module.
Together with the modulus. So you're saying that this one should rather come after the else together with the modulus. So let's try that and see. So let's put that. Usually divided by 10 comes first. So let's put that here. Like this, right?
Yeah.
So let's run this code and see what we get. Now, we're not even getting the initial 0 at all. But the double digits are working all right. But then there's something wrong with that single digit. So that code is not serving us right. So let's go fix that. That's how we debug. We're going to keep trying and trying. Okay. So now I bring it back. That's for the first digit. If our product is less than 9, then I believe because it's the issue is coming from the single digits, it's definitely coming from here. It's definitely coming from here. We need to position this somewhere, either out of this and ignore this else. Let me try this and see if it works. If it works, no, it doesn't work. It doesn't work. So let me bring it back, and then let's try and figure out what the problem is. What do we have here?
Shouldn't they be in the same bracket from for
Come again.
then
Like, it's like you're breaking up. Come again.
I'm thinking for the row.
For the row.
Inside you, we bracket you. Then from there, so from there, the I'm thinking that that should be one thing. And when you pull down, the second,
The-
yeah.
It's like you're breaking up. I'm really trying to hear you.
Hello, can you hear me?
Yes, I can hear you.
Okay, so I'm saying that pull down after four statement. The second one, the one
Use the line numbers. Line what?
line 19,
Line 19.
yes. Then we open the bracket, write the statement.
Yes.
But after that, I don't think line 26 should also. I think they should be.
Oh,
I'm breaking a lot, but I think she may be talking about the code block.
yeah. I think she's talking about the code blocks.
Yeah, so after the first, on line 19, after the open bracket,
Yes.
we didn't close again. You have to close before we use the if statement.
Is that what you're saying, Shura? Because this one controls the inner loop. So all this entire block you see over here is inside the inner loop. Everything here is inside the inner loop, and then this putka is for the outer loop. Everything going on here is inside the inner loop. So we have. So what are you saying? I want to try what you were saying out so that we see if it works.
Bracket before like it. So 26.
Line what?
26.
Yes, the if statement 26.
Can you put the bracket? The
Okay.
bracket after.
So I should move everything here.
No, not to remove them. To the curly bracket. The curly bracket is zero.
For the if statement.
Then for the inner loop, I'm thinking they should have only like it will contain from the bracket we initial from 19. The after curly X removed.
I took out the brackets for the inner loop
The
now.
bracket and-
Yeah, I get it, but after the
29 should be removed. The bracket at 28 should be removed.
So you're saying that I should take out all the curly braces.
Not all. No one. The one you just removed should be there.
So let me open the one for the inner loop then. Because that one controls the inner loop block. Right? I take this out.
Yeah. The 30 pin. Yes. Now we open
And that means that
the L will be removed.
this 2 has to go.
One and the 30, yes, the 30 also has to be removed.
The 30 controls the inner loop. So this 30, if I run, yes, go ahead.
The put car function. Or maybe we cook a comma, we cook a product, how like this initial the function, product type color. Then we do L the modulus. But the modulus is taking care of only the
Single digit.
greater than 9.
The modulus is taking care of the less than 9. Right?
Sorry, here's some.
No, the modulus is taking
Okay,
care
alright.
of the greater than 9 from 10 above. And the division. It is
Uh-huh.
for the now.
Oh, you're breaking up so bad. You're breaking up so bad.
Hello, can I do it now? Can I do
Yes.
it now?
Yes, I can hear you.
Okay, so I'm saying that the product divided by 10, and product
Mhm.
divided by the
Modulus 10.
Modulus 10.
Mhm.
Yes, those two should apply for the numbers greater than 9, so meaning 10 and above. So
Okay.
I'm thinking that they should be together. So where we put
Okay.
the product divided by 10, should rather come after the L.
Okay. So I'm putting your hair like this, right?
Yeah.
Then
Yeah.
then what else? What other change must we make?
For now, that's
So
all I
let's run this and see what we get. Now the problem we're having now is with our curly braces because this one doesn't have a corresponding curly brace.
yeah.
This is what we get when we run that code. Everything as basket. Okay, so at least let me fix the curly brace of the inner loop make sure that everything is
Yeah.
contained in the inner loop. Okay, then great. So now the inner loop is contained. So let me run it again and see what we get. So now we are back to our wait, it actually worked. Yeah, it worked. I remember I watched a certain funny video. The code was working and it's like the helicopter blades were not moving and they were wondering how the helicopter was moving. It's like the code is working, but I'm wondering why it is working. All right. So I think someone should help me. Someone should help me go through it and let's find the logic as to why it's working.
Okay.
Let me
So
minimize it a bit. Okay, so go ahead.
okay, first I didn't understand why you start the zero. But now from my understanding, I'll give that for the time to looking at the pattern, we knew that all the rows will start with zero, all the columns. The first, yeah, the first,
Rows, first column
yeah,
and first row are all
yeah.
zeros.
How like it? The first rows are zero.
Yes.
Then the first columns are also 0
Mhm.
meaning that if we first, I was thinking that if we put her, if we remove the 0, we're going to have something else because we won't get 0 for the first column,
That's true.
meaning that yes, we won't get 0 for
So
the
let's
first column.
try
I understand that.
let's try and
So-
comment this out and then let's initialize this as 0 like this and let's print and see what we get just in case. I mean, so with that we are not getting the initial 0 over here, we only have the comma.
Yeah. Yeah.
That's the problem. That's what's going to happen if we do it that way. So I'm just going to
Okay.
go back.
Yeah.
Yes, I'm listening.
So from what I understand now, the first the first function, the 0 takes care of the first column of the 0. Now when we come to the inner loop,
Mhm.
the inner loop tells us that maybe for starting from 1 iteration to 9, meaning that if the constant is 0, we come down, then we start from 1.
Mhm.
Then from there we know that per the pattern given, we have comma and space for single numbers, no, for double numbers, as we had mentioned.
Yeah, that's true.
Then we know that it's a multiplication timetable. So the inner loop must be multiplied by the outer loop, or the outer loop must be multiplied by the inner loop.
That's right.
So that's why we have a product equal to constant times the column.
The column.
Then we know that for the single numbers, we had extra space.
That's true.
Yes, so we have to put that in, that if the product is less than 9, we should bring that extra space. That's why we brought the space to
That's
do
right.
that for the single numbers.
Awesome.
Else, we know that for the double digit, like we mentioned, that for Putka, we'll have to get the first number, we'll have to divide by 10.
That's right.
To get the second number, we have to include the modulus of 10.
That's right.
So that is what I understand from there.
Makes
So
perfect
it means
sense.
that now, for let me give this example. If the constant is 0, we come to the inner loop. 1 by 0,
Mhm.
we get 0.
Mhm.
Then 1 by
From 0 to
I'm
1.
getting-
No, you're actually on the same path. The constants are iterating for the rows. So everything here is being multiplied by 0, and everything here is being multiplied by 1, and it goes on and on and on. So for the outer loop iteration being multiplied by the inner loop iteration, that is when we have the product in here. So basically, what you're explaining is actually the right thing. So if the product is a single digit, like you said, we print an extra space. Else, if it's not a single digit, then definitely it's a double digit. So just like you explained again, then this is going to take care of the double digit. The first one takes care of the first figure, second one takes care of the second figure. Then when we're done, we print a new line. I think it's that simple and straight to the point. We're able to do it together. It's amazing.
Yeah, we're here.
I think Cheryl was explaining the logic.
Okay. So at what point, where exactly did she get to before we lost her?
No, I actually finished, but I was trying to explain the multiplication part for the outer loop and the inner loop. How, for the product, how we breaking product equal to constant times colon.
Yes.
Like taking the outer loop, how the multiplication, like a practical view of how the multiplication is happening.
Exactly.
That's what I didn't understand. So
The multiplication is an iteration of the outer loop and the iteration of the inner loop. It's actually the simplest part of the entire code logic. So the product is the whatever iteration the outer loop has gotten to times whatever iteration the inner loop has gotten to at any point in time. So that's the product. That's what we see over here. Let's run it for like 2 of them. So let's say at this point, let's take this point for example. At this point, the outer loop iteration is in its 1 iteration. So it has gone and come for the first 0, and it has gone and come again. So it's been incremented to 1. So at this point, the outer loop is in iteration number 1. Then now the inner loop is going to start its iteration all over again. Remember that we have already put car 0. So all these 0 for the first column has been taken care of already. So we don't have a problem with that.
Okay, then that's where. Okay,
Exactly.
I think that's where.
So that's what
So keep going.
Yeah.
Keep going.
that's what this 0 put car is for. You get it? So this 0 put car 0 takes care of all the first column of our code. So we've already taken care of this. Let me even cancel it so that we know that we are done with this. The outer loop is going to keep printing the first 0 of the columns. Okay. Now the inner loop is now going to start its iterations at this point. So we initialize it at 1. So our inner loop initializes at 1. Okay. Now, so while the outer loop iteration is at number 1, the inner loop is now at 1. So this is 1 times 1. For this place, the outer loop iteration, remember, is still at 1. But then the inner loop iteration has moved to 2. So it's 2 times 1. We get 2. For this place, the outer loop iteration is still at 1. The inner loop iteration has moved to 3. So it's 3 times 1, 3. You get the hang of it now. For this place, the outer loop iteration is still at 1. The inner loop iteration has moved to 4. Then it goes on to 9. So when the inner loop iteration is done, then now we go and print a new line for the outer loop. Then the outer loop will be incremented again to 2. So for this place, the inner loop has started all over again. So the outer loop iteration is at 2, but the inner loop is now has started from scratch. So it's 2 times 1. The outer loop is at 2, but then the inner loop has now moved to 2. So 2 times 2, we get 4. The outer loop is still at 2. The inner loop has moved to 3. So 2 times 3, we get 6. The outer loop is still at 2. The inner loop has moved to 4. 4 times 2, we get 8. Then the outer loop will finish its second iteration and then go and get incremented to 3. So the outer loop is now at 3. Then the inner loop will start all over again. So the outer loop is at 3. Inner loop is now at 1. 3 times 1, 3. You get it? Outer loop is still at 3. Inner loop has moved to 2. 3 times 2. And it goes all the way. The outer loop is now incremented to 4. The inner loop starts. So does that make sense to you guys? It's actually really simple.
Yes. Then
So-
the outer loop is actually the constant we have put there in the yellow.
Exactly. That is what I was explaining when I started. The constant you see over here is the outer loop, and that is what controls the rows. So all these orange you see here controls the rows. That's the outer loop. Then the inner loop are the iterations are put in orange over here. So all these small numbers over here, small in orange, are the inner loop iterations that are running. So we are the product in white ink is the multiplication of the inner loop iteration and whatever iteration the outer loop has gotten to at that point. Ernest, you get it?
Yes, I'm over.
Perfect. So that's how any multiplication table. I don't think if we meet any multiplication question again, we should struggle, because this experience that we've been through should have given us a very solid grounding of how we are going to tackle any other multiplication question if we meet it in the future for any interview. And even though we've done it right now, we have to go back and practice. Try and go and print a 7 multiplication. We've done the one for 9. Try and print for 7. Try and print for.
I agree. It's very tricky.
It's kind of tricky. Yeah, it's kind of tricky.
One more thing though, I'm still not sure why the first, when we first ran it didn't really work. We didn't figure it out.
I think it didn't work because this one over here, no, it wasn't this one, it was this one. The reason why it didn't work the first time was that this command, this function over here, I had taken it out and I had brought it before the if statement after the product. So it was over here like this. And the logic was not correct. That's because it's going to print this divided by 10 is going to print the first digit for, if it's a double number, it's going to print the first digit. But the question is that, where is the single digit? It's not taking care of the single digit. It's only taking care of the first digit if it's a double number. So that means that every single digit in the code is going to print 0. And that's why we kept getting 0. That's why we kept getting 0. So we had to move this out of that place and then bring it after the else statement. So that when the first 0 has been printed, our product is definitely the outer loop times the inner loop. And now we come and say that if our product is less than 9, then we are going to just print a space. But if it is more than 9, then we are going to go through this logic. It's actually really straight to the point. If it is more than 9, if it's less than 9, then we're just going to print an extra space. If it's more than 9, then we're going to go through this logic. And with this logic, if it's a single number, let's assume that we come to a single number with this logic. Let's say we are dealing with iteration number 9. I mean product number 9. 9 divided by 10 plus 0 is going to be 0. So the first digit will be 0. Then 9 modulus 10 is going to be 9. So it's going to be 0, 9. That's how come in a pattern we're getting actually there's no 0 before the single digit, but our code is giving us zeros before the single digit. It's because of our logic. I have an error here. Hold on. Where's the error coming from? Let me run it again and look at the line number. Actually it wasn't an error. It wasn't an error. It was the initial one we had already won. I was saying that the single digit had 0 before them, but then I'm realizing that it's just the 9 that has a 0 before it. All the other single digits don't have zeros before them. Just as we see it over here. This 9 over here does not have a 0. But our code runs the single digits and everything all right. But we happen to have a 0 in front of our 9. And then all the other ones work.
Yeah, I think it should be the function we wrote, the less than 9.
It should be less than or equal to.
Yes, exactly.
Let's try that and run it and see. I always like to try. You're right. So our 0 in front of the 9 is now gone. And everything seems to be okay now. Very interesting. It's very tricky indeed. Something like this, you have to solve it like at least 5 times. This same question. Wipe the code. When we are done, when we go back, wipe the entire code.
That's why I asked them to solve this question, because it's very, very funny.
Yeah, and it's good that we put all our minds together. We're able to come up with this logic. So what we need to do now is that when we've gone our separate ways, wipe everything. Try and type it with your own hands from scratch. Start from scratch and write it and run the code and see if it works. If it doesn't work, try it. If it works, wipe it again. Do it over and over about 5 times. After that, you're going to be okay. We're going to be good. Good cry. And that's what I'm going to do when I leave you guys. So time is gone. So I'm just going to talk about pointers right now. What are pointers?